it's not enough to provide that one small element of the algorithm that is part of the bigger system. You have to provide everything around it that is needed to incorporate the technology. That's why when all partners come, we are plug and play with that whole system.
We're understandably obsessed with language models. ChatGPT, Claude, DeepSeek, text generation, document summarization, code completion. But apply these models to specialist industries like medtech, which Anna Barnacka comes from, and they look really quite different. For example, more data is better, right? Well, not always. At MindMics, which Anna runs, they're building medical-grade diagnostics with small, meticulously labeled datasets. Every point benchmarked against gold standard, millisecond level accuracy. It's quality over quantity. Anna's background is as an astrophysicist, and she's applying similar signal processing systems to detect heartbeats through earbuds.
Our philosophy, it's better to have a smaller sample of well-labeled, well-characterized data than a massive amount that actually we don't know if you can even rely on that. So this is where you saw me actually that was even using that benchmark even during the call, because that's what we're using for all of our data collection. So we're not only collecting the data for the ear, but always we're matching it to some gold standard. And that's the key for us. That's why even with the smaller teams, we are able to process and to achieve pretty good results pretty quickly.
Everybody thought the ear canal was just a microphone capturing sound from outside, but MindMics discovered that it's bidirectional. It broadcasts signals from inside the body as well. We don't hear our heartbeat not because our ears don't detect it, but because our brains filter it out. This type of analysis is not an obvious target for language models. This is very machine learning, but it's increasingly being impacted by LLMs and LLM infrastructure.
My background is in astrophysics, so that's what we've been always doing. If you want to interpret any signal from the universe, we don't take it at the face value. We first do the instrumental correction. We first think about, okay, how the instrument, how sensitive it is, especially across different energies, different frequencies. And then usually we measure those and we can correct the signal. So then we know how to interpret it. And that's exactly what we do at MindMics. And again, it's not because our hearing range doesn't end at 20 hertz because our ear cannot detect the lower frequencies, but because the brain has to filter it out, because otherwise we wouldn't be able to function because our body actually is so loud. And what we have done with MindMics, we actually tested it with this hypothesis with the microphones. And we made sure that there was no filters on them. So what is actually very interesting when we dealt with smaller amount of data, still classic machine learning, regression models, classic feature engineering, starting with the first principles of, what is the physics that is driving the shape of the waveform and how that shape of the waveform actually corresponds to the blood pressure.
The foundation models we're using today have been trained on huge text-based datasets, and as such are great at next word prediction. But Anna really needed something different, one trained on human physiology and patient data. Blood pressure varies massively, age, health conditions, time of day. Language models work by surfacing patterns in text. Specialist domains need different training data, fundamental knowledge about the physical world, human physiology, blood flow physics, heart biomechanics.
Blood pressure is very specific. There is a reason why there hasn't been significant innovation in blood pressure, successful innovation. There has been a lot of attempts, but still there is no FDA-cleared blood pressure wearable that would be cleared by FDA to be used for people older than 59 years old or people with different comorbidities. And the reason for that is that physiology is changing significantly from person to person. So where we are now exploring AI is how we can use AI and generative models in principle to help us generalize across different physiologies and find those patterns, because it's going to be very complex to be able to do it. And that's what also, when you think about constraints that will come with the language model, that what we are already seeing, okay, it's for them to achieve next level of improvement within the cost frame that is not way too expensive. They have to have some common sense, because for now it's still they lacking common sense. But that common sense is that what are those underlying principles?
Anna talks more about ecosystems, ML, and algorithms in AI. To monitor the heart in an earbud, MindMics build custom hardware to synchronize data streams at millisecond level accuracy. Heart valve events last fractions of a second. Clock drift between devices can turn a clear signal into static.
What we've done at MindMics from the very beginning, when we were still validating this technology, was a few years ago, actually, when we already saw that, okay, the earbuds were giving us the heartbeats. We started building the cloud infrastructure already then. So we spent a lot of time thinking about how to organize them, and then also how to organize them into data banks as well. So we have the production, so we were the earbuds and it will record. We have a standard databases, standardized databases. We spent at least a year making sure that they are synchronized well, because we had to build a special hardware to get the raw data from all of those devices, synchronize them on one PCB level.
Software teams and builders are now beginning to think about how the breakthroughs delivered by the first phase of AI and AI infrastructure can be applied to less obvious problems. Think domain-specific models that combine specialist knowledge like physiology datasets with approaches from adjacent fields like astrophysics.
And that's what led in physics and astrophysics into a massive development. So, for example, in my case, we will go back to also using AI as well. But actually, when you think about, because to your point, now everybody's excited about the power of using the language models, because it's something that can actually make everyone's life easier. The context would be actually the human physiology, and especially the physiology of the heart. This is combining that as the next level will be very exciting.